Welcome back to the deep dive. Today we're jumping into something that, well, looks pretty technical on the surface, an index of engineering drawings,
Right.
specifically for double-circuit primary pole-top assembly units. Sounds dry, maybe?
Yeah, it can seem that way.
But stick with us. Our mission here is to dig into the surprising detail and, frankly, the clever engineering packed into these everyday power poles. You see them everywhere, but there's a lot going on up there.
Absolutely. And that list you mentioned, particularly looking at parts of the double circuit RUS.pdf, it's not just a list of names. It really is like a window.
A window.
Yeah, a window into all these very specific, highly engineered parts. Each title, each number, it points to a component that's absolutely essential for keeping the lights on safely and reliably. They're like little solutions to big physics problems.
Oh, okay, I like that. Solutions to physics problems. So it's like we're looking at the building blocks of the grid right on the pole top. So looking through this index, okay, VD1.81 and VD1.82 jump out. Single support on crossarms. Tangent. Tangent? That sounds like, well, just straight lines, right? Low stress.
That's a good way to think about it initially.
And,
yeah. Tangent assemblies, like that VD1.81, they're really designed for those straight stretches of power lines.
Okay.
The main forces are, pulling along the wire. So the design can focus on being cost-effective, easy to put up, doesn't have to fight strong sideways forces. It's sort of the default setup for long runs.
Gotcha. The workhorse. But then, right below it, I see VD1.81L and VD1.82L. The L is for large conductors. That's not just using a thicker wire, is it?
Oh, definitely not. That L signals a big change, a really big change in what the structure needs to handle.
How so?
Well, think about it. Much heavier cables, right? More tension over those long spans. So you need beefier crossarms, stronger insulators. Everything has to be engineered to handle significantly more weight and pull.
Without sagging or breaking down over time.
Exactly. It's about managing those increased loads, preventing too much sag, making sure everything stays where it should, electrically and physically. It's a materials and mechanics challenge.
Makes sense. And then there's another variation, VD1.81P and VD1.82P for post insulators. So even the type of insulator changes the whole assembly designation.
It does, yeah. Post insulators aren't like the hanging strings of discs you often see. They're more rigid.
Okay.
So they might be chosen for places with high winds, maybe heavy pollution because they don't swing as much and offer really solid electrical isolation. But because they're rigid and shaped differently, the crossarm, the mounting hardware, it all has to be designed specifically for them. How the load transfers is different.
Wow. Okay, so every little detail matters. Which brings us to the VD2.91 series. Double support on crossarms. Now we're talking two supports. That's clearly for more demanding situations.
Definitely. Double supports like the VD2.91 are for when you need much higher strength or maybe some redundancy. Think multiple circuits on one pole or really critical lines.
Just spreading the load.
Right. You're dealing with heavier total loads. You have to distribute them carefully across 2 points, manage vibrations, keep everything spaced perfectly to prevent arcs. It's just a much more robust structure overall.
Incredible. And it's not just about holding things up straight either. The index lists guides, like VD 3.1G, a suspension angle guide, and VD 4.1G, a dead end angle guide. These sound like they're dealing with turns and stops.
You nailed it. Those are critical. An angle guide like VD 3.1G is all about handling the sideways pull when the power line changes direction.
Which must be significant.
Huge. It's a major stress point. So that assembly has to be built tough to resist that side force. Now, a dead-end angle guide like VD 4.1G, that's even more extreme.
How so?
Imagine the line just stops or takes a really sharp turn. That assembly has to take the entire pulling force of that whole span of wire, concentrated right there. It often needs multiple insulator strings, really specialized hardware to safely anchor that immense tension.
Okay, wow. And what about getting power off the main line? I see VD 5.91G, a three-phase tap guide.
Ah, yeah, that's fundamental for distribution. That's your junction box, essentially. It lets power be safely tapped off the main three-phase line to feed, say, a neighborhood or a factory.
While keeping the main line balanced.
Exactly. Got to maintain integrity.
Yeah.
Requires careful design for insulation, connections, fault protection. And then you get even more complex things like VD 6.91, double dead ends on crossarms, feed-through. That sounds like lines are ending and passing through.
Right.
Which means you're managing tension from multiple directions, sometimes opposing forces, all on one structure. Each one of these numbers, these VD codes, it represents a very specific job, a specific set of forces it needs to handle reliably. They are not interchangeable.
So let's just recap this for you. We
Right.
started with what looked like, a pretty boring list of parts for power pools.
Mm,
But digging in, we found this incredible world of specific engineering. From basic straight runs to handling huge conductors, different insulators, managing forces around corners, at dead ends, tapping off power.
it's all there.
The level of detail needed for something we barely notice is, honestly, it's kind of amazing.
It really is. And what stands out is how purpose-built everything is, whether it's that VD1.81L dealing with heavy wires or the VD4.1G anchoring a line at a sharp turn. Each one is a tailored solution.
Not just generic hardware.
Not at all. These specific units are vital cogs in the machine, ensuring the whole power grid stays stable, safe, and can adapt to all sorts of conditions.
So here's something to think about. Next time you glance up at an electrical pole, try to remember it's not just wood and wire. It's an intricate assembly. Specific parts like those VD codes we talked about, maybe a VD1.81P or a VD4.1G, each doing a crucial calculated job. It makes you wonder, doesn't it? What other everyday things are hiding that kind of complex, hidden engineering right in front of us?